Okay, let's start. Okay, first of all, I would like to make some announcement quickly. Okay. About your lab test 1 is going to happen next Wednesday during your registered lab session. For that, I already posted a guide, read it through about the expectation and strategy. And the practice questions is only meant as an example. So what you should do is go to the section about coverage for the lab test. You want to study the coverage, that's more important, okay? Especially writing contracts and being able to write basic IFO, okay? And also contracts and implementation. For your lab number 2, it will be released just a little bit later tonight. It's already done. I just need some final proofread to make sure everything's okay before it's released. It's going to be about iterator pattern and generics. It will be a very challenging but rewarding lab for you. Okay, you will see. You'll get enough time to do it, don't worry. Okay, I would like to start our lecture just by doing 2 more examples for postconditions. Lab 2, you will see that when I release it. You have enough time, don't worry. No, it's like lab 1, right? You got a chance to do it, yeah. Okay, let's start with this example here. So take this opportunity as like a mock-up exam. Okay, how about that? So this is kind of the question you will receive in the exam. Have a look at this fragment of code here. I hope I didn't make any silly mistake about wrong variable, I hope, okay? Let's say we have an array of string called A, and we got change at. That's kind of the feature we discussed before, okay? And now this contract is basically what I said would be complete. I put in quote, complete. It's not exactly complete, I can tell you. Basically, let's review very quickly. So this feature over here called change at is going to modify at a particular position I, and then it's going to change that position to S. And then, of course, the require, I didn't really put it here, you can assume there is a require precondition saying I should be valid position in the array, okay? And now what we got over here is to say go across from lower to upper is J. And then if J is equal to I, that means that's the one we want to change into S. In that case, the element should be the same, right? Should be changed to that particular elements. Otherwise, if it is not the same, that means those elements should maintain unchanged. Exactly what we say here. All right? That's basically a very quick review of what we said so far about all expression, writing complete postcondition, etc. However, even you have done all of these, this is still not complete. Okay? Can anybody think about a scenario? I wouldn't expect you to give me the answer. The answer is incredibly easy. Okay? But now the explanation itself is more important. The 2 shaded blue over there is hints. Okay? Before I reveal the hints to you, why don't you think about it? Okay? Throw ideas, that's okay. Doesn't matter how silly it might sound, doesn't matter. What's the problem here? You mean the deep twin? I can tell you the deep twin part is okay. Yeah, I can tell you. Basically, the deep twin part is you review the lecture, you will know that we'll just make the deep twin of the whole array. So aliasing is going to affect us. It's not. Okay? So that part is fine. Somehow we are missing some condition over here so that there might be some evil supplier that can actually mess around with our array so that it won't be caught by this postcondition. Okay, want to try? Yes.
S is empty.
If S is empty, you don't have to worry about it because it's okay. We can definitely change a string to empty string. Okay, I'll try the back first. Okay, yes.
We're going across the new array, like from the lower to the upper.
Okay.
So if the supplier change the size of the array, and that is like an extra element that won't be checked.
Oh, okay. You're definitely on the right track. Let me just repeat what you just said, but it's not complete yet. Let's help everybody. What you're saying is, let's say the evil supplier, not only that they try to modify position I, and they didn't change anything about the rest of the array. However, they try to grow the size of the array to be 1 larger. Let's say, for example, what would be the consequence of that, though? Why is that a problem? It's definitely on a good track. I'm just trying to help you complete the answer, right? Yeah. Yes?
Maybe to make the array bigger, that A dot D twin and the A will be the same size.
Okay, I agree. So that means old A dot deep twin, that's old version of the array, and the new version of the array will be of different sizes. Again, what's the consequence of that? Index out of bound exception. Okay, that's good. That's exactly what's going to happen. Okay, let me illustrate that. So my first hint is exactly that. I was asking, what if A dot count, the new count, is strictly larger than old A dot count, meaning that we are trying to grow the size of the array. Okay, let me visualize that to you. So let's say this is the current array A, which is pointing to, let's say, just an array like that. Let me just make it very simple, 3 elements. And let's say I over here is simply just, indices would just be 1, 2, and 3. And let's say index I would just be 1. So let me make it 2. That means we're trying to modify this particular slot and change that to S. Let's say the evil implementation does change that to S. Okay, let's say. Okay, let me draw it a little bit better. Let's say after the evil implementation, they do change this to S. And then they also keep the rest unchanged. Green means unchanged. So that means this part here is going to be satisfied totally. However, they do something extra. What they do is, I'm going to draw in pink, they simply grow the size of the array and do something evil over here. I'll put evil here. Okay. So now, when you're trying to run this array over here, what's going to happen? Because according to the post condition over here, A dot lower and then A dot upper. So now, what would be A dot upper in this case? 4, agree? Okay, in that case, that would be 4. From the first until the third iteration, we are fine. Okay? So now, oh, by the way, because, one more thing I forgot to mention. Because we got old expression over here, so when we say old A dot deep twin, it was actually, let me just redraw this, okay, so you don't get confused. Okay? So this green part over here is going to cache the value, so I would say old A dot deep twin is simply going to make a deep twin of the array of size 1, 2, and 3, right? A deep copy. And then the evil supplier is just going to grow the size of the array to be something like this. Okay, so now if you compare the 2 versions of the array, the dark one and the green one, right? Apparently they are of different sizes. And now what's going to happen is when you reach the final iteration when j is actually equal to 4, in that case, when you try to do this, when you say old A dot deep twin, and then at index 4, is there index 4 for this array? No. So it's called a contra violation. You can think about in Java term. Array index out of bounds exception or violation. That's the most important part to understand for this example. Because the evil supplier, again, every time if I ask you the question about whether the post condition is complete or not, think about what can be an evil supplier. They try to satisfy all of these, but they can still do something that's unexpected. If that's the case, that means your post condition is not good enough. Okay, any question about this? Okay, good. Now, how do we fix it? Check the counts. Why don't you suggest one solution to me? I agree with you. I got to check the counts. Yeah. Yeah. Just another post condition you meant. Yeah. Spell it out for me, please. It's A, right? Mm-hmm. Exactly, true. Thank you. Okay, and that'll be it. And the reason we put this new post condition beforehand was because post condition are checked from up to bottom. So this has to be checked first. Yeah, oh, you mean it doesn't compile or simply break at the runtime?
It would just, whenever I would say,
Uh-huh.
when we go to the bugging area and I would write an expression old a.count, it would just say like it doesn't exist.
Maybe show it to me tomorrow in the lab. It could be something that's kind of outside this discussion. I will talk to you tomorrow. Yes, go ahead.
Could you also in the post condition just do the tilde, so do the a tilde old a?
Okay, let me just write down what you're suggesting and then let's judge. So what you're suggesting is, or before I say that, okay, this is the correct solution. One way to do it, okay? Okay, sure. What you're suggesting, I'll put in purple. You're saying to say A tilde old A dot deep twin. Is that what you're suggesting? Okay, no problem. Okay, that's a good question. So guys, question for all of you before I attempt my answer. The purple one, what Michael just suggested, what if we simply put A tilde, which means A dot is equal, right? The array, the two array, the old version and the new version, they must contain the same contents. Yes, speak up, please.
It's a deep twin, so you're creating new object for every single thing in the array, so it's not going to be the same.
Well, actually remember, tilde here is not going to compare references. It's going to compare contents. Okay, anybody? Chelsea, yes.
We want to change one of the indices, so you're like.
Exactly. Yeah, exactly. So this purple postcondition is another candidate for good exam questions, right? So there's nothing wrong with the expression itself. It's just not suitable in this context. What we put as purple over here, I'll put the notes over here. This one, sorry, I'm just running out of space. Can I, if you allow me, I'm just going to put an arrow over here. The purple one here is not appropriate because it allows no change from the supplier. However, the very intention about this particular feature here is to change at index I. At least that would be the exactly change we want to make. But your purple postcondition is being too strong, right? Yeah, but you know, it's good. It's good. It's good for discussion. Okay, one more question. Yes?
So does this line actually like work if I'm just trying to check if they're equal, if the array stays the same?
You mean the purple one, yes? Yeah. That's correct. When you say some objects tell that the old deep twin version of that object, that means they stay exactly the same. That's correct. You might need something like that in lab 2. You might need it, okay. Okay, that's about this example here. It's not too difficult, but you gotta be very thoughtful about what can happen. Okay, let's do one more. Final one, before we go to Iterator.
Please, what was the second?
Huh? Which one? Which one? Oh, that's it. Because so the extra postcondition we added was this guy here, right? A.count is the same as old A.count, so that's the one we're adding. So as long as you add it before the original cross, you'll be okay. Because that one enforces if you can ever reach that particular postcondition, the sizes of the two arrays are just the same. So you cannot run into the array index out of bound contra violation. Yeah, so that's this. What's behind the second? Oh, that's behind. Oh, yeah. Good. Oh, yeah, very good. You're curious, right? Basically, actually, that's just the symmetric question. What if A.count smaller than old A.count? Basically, that simply means the even supplier, they simply try to maybe shrink down the array, right? The same idea, yeah. But the green one that we just introduced is, the one that we try to introduce over here is simply going to check that as well. Okay, yeah. Okay, so now let's go to the final exercise for postcondition, right? So far we have seen, this is number 4 we have seen since last time. So try to study them carefully, okay? So now number 4. So this is a query rather than command. We are taking an array of integers, which may be negative, positive, or 0. What we want to return is just another array of integers. And let's say for the precondition there, we'll simply say there should be no duplicates in the array, let's say, to make it easier. No duplicates of the number. And for that precondition, I'll leave that as an exercise. But we will go into it in a different context today. So let's not worry about it. So now for the postcondition I have over there, let's see. What I'm trying to say is, across the result, which is an array of integer. And then I simply say every integer there is strictly positive, which is what the title of the method is telling me to proceed, right? That may contribute something to the contracts. However, is this postcondition complete? Okay, so now, good. That's a good first step. Give me an example of the supplier, or actually, you know what? Give me a very simple evil supplier that can easily satisfy this post condition here, but simply does something ridiculous. Well, this post condition does require the supplier to give us all positive numbers, right? Okay, anybody from here want to try? Go ahead. Huh? Result is empty. It doesn't really matter because if result is empty, that will simply give you true, right? For all, right? So that's not an issue.
There's some positive in the array given, but if result is empty.
You're okay. That's one. Okay, although that's more like a boundary cases, right? Okay, sure. Okay, nobody from here. Okay, go ahead. You just change every number to 1? Okay, in which case, because in the post condition over here, we are not really checking to see the array hasn't changed, right? That's one thing. Now let's focus more on the return. Well, what you're saying is, okay, actually both are valid. Both are valid. What the first case is, let's just talk about different possibility. What you just said in the beginning, let's say if the input is simply, let's say 1, 2, 3, 4. However, the return is simply just empty array, right? I agree. Number 2, let's say over here, 1, 2, 3, 4. It returns something, let's say, it also return 1, 2, 3, 4. However, it modify everything else to be, let's say, -1, -1, -1, -1, right? The post condition doesn't care, right? That's good. That's good. Anything else? Let's say we do not modify the implementation. Okay? Let me just add a constraint for you. So let me change the question a little bit. Let's say over here, I'll simply say A tilde old A dot deep twin. Let's say we simply don't modify the array. Okay. Go ahead.
What if the result the length of it is larger than the length of the original?
Okay, sure. You're saying that basically that's more like a specific case. Okay, I'll take this one more. Okay, so now for example, if we got 1, 2, 3, 4, and then we simply return maybe 1, 2, 3, 4, and then how about 5 as well? We're giving more, right? All are positive. Basically, number 3 can be generalized to the follows. Let's say we simply give 1, 2, 3, 4. However, when we return, we simply return something that's totally different. What about 5, 6, 7, 8? Right? So you can see this post condition here is pretty much useless, even though it looks fancy. Right? Yeah, question?
Yeah, I was about to say that this is pretty useless because
Yeah.
you receive A, but you don't know if we're actually returning A. So shouldn't you compare A to the result?
Oh, actually, the intention for this feature query over here, it doesn't really require to return just the same object A. It doesn't require. It just requires to return an array where the array store exactly those positive numbers in A.
Also, it doesn't have to be.
It doesn't have to be. Actually, it shouldn't be, right? Right. Okay. So actually, 1, 2, and 3 are both valid. Okay, they're both good. Okay. So now we want to give a little bit more post conditions over here for you to think about. Okay. So now the one I just put in to say A, to say the parameter doesn't really change. That's one thing. Okay. And now, how can we avoid this case specifically? Let's say the pink one. Let's say we simply give 1, 2, 3, 4. However, how can we stop the supplier by returning something, even though they're all positive, but has nothing to do with the original array? What should we do, conceptually? Yes?
Go to the new array and see if all array has each value.
Yeah, true. That's true. Okay, so now basically what we should do, I'll write it down in math. You can translate it into iPhone. Okay. Basically, what I gotta do is I'll give you one version here. So I might say, first of all, for every, let's say the result over here, right? That's the result. For every I such that 1 less than or equal to, actually, I think there'll be a better way to say this. for every just x, element x, such that x is an element of the result. You can easily do this by just a cross over the array, right? And then it should be the case that x larger than 0 and a, the parameter, x is also a member of a. Okay? Does it make sense? And what I'm trying to say is every element you collected in the result, first of all, they must be positive. And number two, they must be a member of the original array. Okay? However, this one is not so good. Not yet. Yeah, actually, this doesn't guarantee you actually include everything that's positive in the array. Basically, think about this. This one here, I'm just trying to explain it mathematically to you. Think about pos over here. Let's declare this set to be all positive numbers in A, the input A. Let's say this is a set, okay? What we are doing over here is simply making sure result is a subset of pos. Agree? We're saying every element in the result should be an element that's positive in pos. Guys, do we agree? Mathematically. So now, once we've seen this mathematical expression here, what's missing in order to prove result and pos are completely equivalent?
The same size, A, size.
That's one way to do, right? So now, in order to make it complete, I'll write it in red. You got two alternatives. Either you can say A. Okay, for A, it's a bit tricky, right? How do you say the number of positive numbers in the array A, right? Unless you have an auxiliary feature, right? Okay, in that way, you can do it. Okay, I'll say, you gotta say number of positive numbers in A is equal to result account. For that one, you can just use the auxiliary query, okay? But number two would be easier. Number two, I'll just say version B, right? Version B, how would we do it?
For all x in A such that.
Exactly, the reverse. I agree. Thank you. Basically, we're just going to say, in addition to this, we're just going to say pos is also a subset of result, right? Mathematically speaking. In order to prove two sets are equivalent, one should be the subset of another, and vice versa. Okay? Let me write it down. You're going to say for every x such that x is a member of A, it is the case, you can say x larger than 0 and x is a member of result. Okay? Yes?
What if A is negative numbers then?
Oh, remember we actually got over there x larger than 0, right? We got to make sure everything. Oh, thank you. I think I'm just missing one logical operators over here. You're right. For everything that's in A, I mean x larger than 0 implies, right? Very good. Okay, so guys, any question about this? Very good, I like that. The reason I'm talking about this is be careful because you might need this kind of bidirectional subset relations all the time. Okay, please make sure I understand that. Yes?
So the array can have negative numbers and positive numbers, right?
That's correct.
But if it has a positive, then we gotta make sure it belongs to a result.
That's correct. So that's exactly what B is trying to say. So the blue one is trying to say every x, every element in result is exactly positive and they are a member of A. And then B is pretty much saying the opposite. But for B, we got to use implication because we want to say for negative numbers in A, we don't care. We only care about those positive numbers.
Cannot we make that as a precondition of the element should be positive? Like,
Yeah, but since we go with the existing requirements, so we simply say just no duplicates. But for whether that's positive, negative, or 0 in the A, we don't constrain that. Yeah.
Sir,
Yeah.
I understand why we have to use implication, but why doesn't AND work as well?
And wouldn't work. The question was, good question. The question was, why did I change from the original, let me just use that, how about I use a pink. The question was, originally, I used conjunction over here. Why would it not work? The reason is follows. What if, let's say, A is the following array? Let's say we got 3, we got -1, we got 4, we got 5, we got 6. Okay? Since we are going across A over here, as soon as we go to the second iteration, which is -1, so now what we have is -1 larger than 0, and -1 is a member of result. Now in this case, -1 larger than 0 will be false, right? Rather than don't care. Because we don't care about negative number in the input. We want to make sure only the positive numbers are included in the result. That's why. It's a very good question. It's a subtle point, but it's really important. Yeah, so final, yeah, again. So what will be the final answer? The final would be, you definitely have to include this guy here, for sure. And then choose either A or B. However, A requires some auxiliary features to figure out how many positive numbers on A. That one, if I say in the exam, I don't allow you to have auxiliary queries, then you're going to go for B, right? Okay, A or B, either one. Okay, anything you want me to clarify further? Okay, but please revisit the example about how might I take just one more, and then you can talk to me after class. Okay, yeah, yes, please.
Since A has a negative number, then we don't care about it.
Correct.
Does that mean that the results might be bigger and the size is smaller? So it's smaller in the size than.
Okay, so basically you can see we got blue. Okay, let me explain very quickly. So let's call this. This is for sure need to be included, right? Okay, this one makes sure the result does not contain more than what's in the pos. Okay, and then when you choose B, let's say, let me call that number 2. This one makes sure the pos does not contain more than what's in the result. So if you combine these two together, they're just equivalents. That's basically when you say two things are a subset of each other, they are equivalents. Yeah, that's what we're doing. If you only look at one of them alone, it's not complete. You got to look at both of them together. Okay. Okay, good. All right. If no question, let's move on to a new topic. Okay, so before we talk about the iterator pattern, I would like to just review very quickly about how to use generic parameters. I'm pretty sure most of you have seen that already, but I just want to do a quick review and mention something a little bit more relevant to your lab 2. Especially how you use lab 2. Basically, for lab number 2, you have to be very aware of how you can instantiate generic parameters for your class. Basically, you will be given some unit test. And then you have to figure out exactly what methods and classes you have to declare in your model. And you better do this exercise very thoroughly, because most likely it will be the basis for your lab test 2. Okay, so just to give you a little bit more motivation. Okay, but it's an important exercise, not specific to IFO, but to really be very comfortable with generic parameters. Okay, okay, let's now have a look at the slides for generic parameter. So for now, we're going to revisit the idea about generic parameters a little bit later after we review inheritance. But for now, it's only about how to use it. Okay, some insight into why generic parameter will be better, this some idea. We'll talk about it later. Okay, let's use an example. Let's say I have a class StackStack. Okay, why do we need generic parameters? So we start by saying, what if we don't have generic parameters? Okay, StackStack, and then we have implementation array of string, because every element in the stack will just be a string. And then we have some counter over here. I don't need to bother you with that. Pay attention to the types we're using here. As you can see, I try to highlight in yellow something you want to pay attention to. Because currently we are talking about StackStack. So everything you can see, the type of the implementation there is an array of string. And also the top of the stack should be a string. And if we want to push something into it, it should be a string. Okay? Now, some question or observation to think about. Now, oh, actually, there's a little bit typo here. That should be StackStack. Okay, I'll change that. The way we implement the StackStack, which means last in, first out property, do you think the lethal property really has anything to do with the type of the element being string? Let me make myself clear. We are basically talking about two concerns over here. One is about how the collection works. How the collection works. In this case, is last in, first out. And number two is about the type of collection members. And in this particular example, we talk about string. So now a question for you is, do you think the reason that we chose string has anything to do with the lethal property, or is completely dependence? Independence, right? Because all you got to remember is, in order to implement the lethal property, all you got to do is to make sure, for example, over here, you're going to maybe, when you try to retrieve the top, you'll return either the front or the end of the array, right? That's it. It doesn't matter what the type of the element is. Okay, that's observation, a very important concept. And I want you to, beyond this particular example, always think about, for collection, why do you see collection classes in iPhone, in C Sharp, or maybe in Java? Why are they all generic? It's for exactly this reason. Because for number one, it's all about how that particular data structure should be implemented, like a heap, or like a stack, or like a queue, or whatever. It has nothing to do with what's the member type in the collection. So these two are completely separate. Okay? Now, carrying this a little bit forward, let's consider how would you implement another class called a CountStack, another class. So now let's say I'm not happy with just having a stack allowing a string to be stored. I want to have another stack storing account objects. Apparently, I need another class. Would you imagine this class would be very similar to the string stack? How similar will they be? Or how different will they be? Aha, exactly what I highlight over here, right? Just replace string by account. That's all you got to change. That's it. But to do that, you got to duplicate all the code about how the stack works to implement the lethal property. Okay, let's have a look at that. Okay, if you look at that, basically exactly what we predicted, they look just the same, except that we are using account, and account over here. Okay? Okay, the same idea to reflect. And then, what if I want to have another stack for a stack of heap? What should I change? Again, I'll change from account into heap. So now we are duplicating code all the time. So that's not a good design. That's a lesson. Okay? So the idea about generic parameter is very easy. Okay? From the user's point of view, let's have a look at this. Over here, I'm putting the two classes together, but potentially you can have many classes which have very similar control structure. The only difference is the type of their member over here. That's the only difference. Okay? So now the idea about generic classes is to say, I will have only a single class, maybe just call it stack. Okay? And then this string over here versus this account over here, they are completely independent. That's something I can factor out. Okay? So now you can think about these guys over here is one possibility. And this guy over here is another possibility. Okay? What I would do is, when I try to declare this particular class called stack, I'll simply declare at the class level something called G. And G simply just like a parameter name. You know, when you declare a method, command, or query, you simply put a parameter, right? Just a parameter. So it does not have to be called G. As long as G does not clash with any existing class name, you'll be okay. So in lab number 2, you will see quite informative names for the generic parameters rather than just G or H. Okay? So once we declare this G over here, first of all, that's a declaration level. So now G can be used for the rest of the class for stack. Okay, that's the idea number 1. Okay, are we comfortable with this idea? So it's about imagining all the possible instantiations of the member type for stack, which are the factor them out into a single parameter type called G. Okay? And now, that's how you think of it. And let me just switch to another slide over here. This is the final outcome. Okay? So now if you look at that over here, stack is declared to carry generic parameter G. In the case of lab number 2, you got 3 generic parameters to worry about. Okay? Just to make it more fun. Okay? So now when you have implementation, so now rather than having string or account very specific, we simply say G. So now when you look at the G over here and the G over here, they mean they have different meanings. Anybody can tell me? Given that you have seen many generic parameters in your 2011 and maybe a little bit in 2030 as well, right? Can anybody tell me what's the difference between the G that's declared besides the stack class and the G that's besides the array? I'll give you a little bit hints before I take your answer. One depends on the other. Well, we don't really see any inheritance just yet, because when we got constrained genericity, we got inheritance, but we don't have to worry about it. Yes? One is declaring, the other one is initializing. I like the part about declaring, but not really initializing. Not really, yeah.
Maybe not initializing, but rather just defining or
Not really defining. That's not the term.
The one by the class specified with the client can put any value they like there as long as it's specified.
For the first G.
Yeah.
Yeah.
And the rest of them depend on the particular instance of the stack, what type
That's
of G that the client specified there.
That's exactly right, okay? So now let me just repeat what you said. Basically, this one got here is like what you said, is declaring. This one declare a single generic parameter called G. And when we see from the client side, when we declare stack, typically we just give an instantiation, just called string. In this case, that means this G over here will be instantiated by string. However, all the other G over here, okay, I'll put them here. They depends on what the red one over here, what G is instantiated into. Okay, that's the difference. Basically, at the class level, right after the square brackets over here at the class level, you declare several, as many as you want for the generic parameters, and then you can reuse them. So now, let's think about a little bit more, okay? So now, let's see this. So now, over here, let me just wipe it, make it a little bit cleaner for you. So now, look at that. We have SS, we got SA. We got 2 stacks, okay? One is declared to be of stack of string. The other one is declared to be stack of account. That's exactly the different instantiation we can make, right? In the first case, when we say it's simply instantiated into string, that means this G over here is instantiated into string, I'll say S. And the consequence is, it's as if every G over here that this one is dependent upon has been replaced by just string. So that gives you the first version of string stack we had previously, okay? And then if you look at the second one over here, the second one, let me use green. And this one here, we're instantiating the G to be accounts, right? In this case, G over here would be instantiated into, I'll say A for account. In that case, every occurrence of G will now be instantiated into A. Right? It's a different value. Guys, does it make sense? Okay, just about from the user's point of view, that's all you have to know. But when you really practice with that, you have to watch for exactly what you are replacing that for, right? Yeah. IFO convention, even though it's G, H, in Java it's an E, K. However, in Lab 2, we follow some different convention, my convention, right? Well, actually, some people do that as well, where I'm trying to give you more informative type for the generic parameter. For example, I give you data 1, data 2, and also key, right? So the name itself doesn't really matter for the generic parameter as long as they do not clash with your class names. Yeah, they're just like a parameters. Okay. And of course, this is not specific to IFO, right? Even in Java, C#, or other OOP, so they will just support this.
Is this generic design pattern, like using generic durability class?
Generic parameter is not really a design pattern. It's a little bit more, slightly more advanced features in OOP. Basically, rather than having a stack of objects, we'll have a heap of objects. We're making a heap of G, right? That's a more advanced feature. Okay? But many of the design patterns itself, they use generic parameters that we'll talk about. Okay, so now let's do a little bit more exercise, just to get yourself comfortable, and then we can move on to Iterator. Okay. So now I want to do one more exercise with you. Okay, so now, that's a generic class that we talked about. So now, of course, about the replacement of G by whatever user instantiated type. Okay, that's something we also went over. What I want to go to is this particular slide just to check your intuition. Let's say we got these two variables. One is SS, the other one is SA. Okay, so now in the case of SS, every member in the stack is a string. In SA, every member of the stack is a count, right? Let's try to see if things should compile or not. Okay, so we got S and A. So now, SS dot push A. Should this compile? Okay, good. It actually be quite obvious, right? Because in this case, because we are talking about SS and it has been instantiated into stack of string. That means it is this particular version over here that's blue. Because we instantiate that into string. That means when we talk about push, the V over here is of type string, right? That's the first version that we talk about. Okay, that's how you check. Okay. What about this? If I say ss.push, I'm just pushing an account object into it. Can I do it? No, the answer is you cannot, because we know that because ss in line number 3 has been instantiated into string type. So you can only put string only string. Okay? That's something you want to, that's very basic. Okay. Guys, are we okay? Do you need more explanation? You're fine, right? Yeah, exactly. Yep, that's exactly how we explain it, yeah. Oh, you mean the expression over here? Oh, I didn't say create ss.make. Yes, that's a good catch. Yes, I agree. Because of voice safety, yeah, I should have done that. But just for illustration. Of course, before line number 7 and 6 and 7, you should have said create ss.make, create sa.make. Let's say we did that, let's say. Okay. Good, I agree. So now what about this? Can I do this particular assignment? Number 8, s is assigned to ss.top. Good, because very quickly, because now we talk about s is a string over here, and ss, we're talking about the blue one over here, the blue one, and then the top is going to return s type, right? Good. Okay. How about this? Line number 9. ss.top is going to return a string. You cannot assign a string to accounts, right? Okay. Okay, one more. How about just one more? I don't want to bother you too long. What about number 10? Aha, exactly, because now if you compare exactly line number 10 and line number 7, line number 7 is not good because the context object ss has been instantiated to string only. But SA in line number 10 has been instantiated to account only. That's the difference. Okay. Okay, so the rest will be following very similar logic. Okay. Oops, I don't want any updates. I'm worried that if I say OK, it's going to go ahead and do updates. That would be better. Just hide it. Ignore that. If I say learn more, it might be even worse, right? It would just give me it would show me lots of things. I got to scroll all the way to the down and sign. That's not good. Okay, ignore. Hopefully, it wouldn't bother me for another 60 minutes or something. Okay, good. Okay, guys, any question about generic parameter? I think that'll be what we need to know as far as now is concerned, right? Later, we'll talk more about more about the inheritance side about generics.
So I know like for generics you have like if you give a generic you can use any type of string count integer or whatever. Like let's say you want to implement it in a way where you have both types minus certain ones. Like let's say you want to be able to do it with strings and count but not with integers. So we like specify that with generic?
Yes. Let me mention that very quickly. You will see that kind of construct in lab number 2. You're basically talking about constraint genericity. Let me mention that quickly. You have this idea in both Java and IFO. Let's say in Java, okay? If I say I have a collection class, collection, and then angle brackets, I might say, let's say type E, and then I can say extends. For example, comparable. Remember back in 2030, when you have a class that's comparable, you got to implement the compare to method, right? So that's something you're familiar with. In IFO, you got the same idea, just the syntax a little bit different. Okay, I'll show it to you. In IFO, class, collection, and then square brackets, okay? So now you would say, for example, E, I would say just make E. And now rather than extends, you would say this, dash greater than, like an arrow. Comparable. Okay, so what does this really mean? I think in some way, I think the Java version there, the keyword is a little bit more informative, my personal opinion. Okay, just for that reason. So now what that means is, when a client must declare, let's say, some C of type collection. So now, what can they put over here? Can they put person? Yeah, exactly. You can put any class as long as they are a descendant class of that particular class over here. Okay? So this can be any descendant class or child class. Well, actually, child class is too specific. It's immediately below, but descendant is down in the hierarchy. Any descendant class of comparable. Okay, that's something maybe you have seen already. So I just want to do a quick review. So that's how you constrain the genericity. Okay, so we're going to use generic parameter very often, so it's good to have just a very quick review so we can assume everybody's on the same page. Okay, okay, let's go on to talk about a new topic. So first of all, let's do a very general slide about design patterns. So we're going to talk about a number of common design patterns. Remember one of the reference books I recommended in the syllabus is it's more like a catalog of all the design patterns. They got about more than 30 or 40 patterns over there. We don't cover all of them in this course. We need to choose some interesting ones that's more sophisticated. Okay? But we start with something easy, iterator and singleton, and we'll do more, maybe after the reading week. Okay? Just start with simple. But basically, for each design pattern, they basically represent the solution to some recurring problems that happen in the software industry. Meaning that, let's say you graduate from this course this fall, and let's say you go for some job interview. Very likely, at some point, they will ask you about design patterns. They will say, oh, so now we have this particular problem here. Do you think any existing design pattern might be able to solve it? That could be an interview question. Okay? So I think that is some useful stuff for you. Okay? However, for every design pattern, you have to know this, first of all. Well, it's just about heuristics, about common strategy for people to solve the problem. But caveat, that's really important. A pattern is only suitable for certain problems. That doesn't really mean you can apply the iterator pattern to every problem you're given. You have to know what's the context and what's the limitation. Okay? Okay, you want to understand the problems before the solution. So now, before the exam, you might have learned about maybe 4 to 5 design patterns in the course. In that case, how can you study for them? First of all, you want to gather a group and then talk about what kind of problem can be solved by this particular pattern, number one. Number two, if I try to solve it, what's the design architecture? Number three, you can talk about a little bit coding. Coding is a secondary issue in this case. Number four, what's the limitation for applying this particular pattern? So every pattern, we'll talk about limitation as well. Right? You want to learn the full story. Okay, this slide here, I want to remind you. Always remind yourself about this particular slides. Okay, let's do the first pattern for this course, iterator pattern. And for this, we can also introduce a very important concept. Okay, but that's what I would typically do. I will give you some motivating examples, simple ones, and then we try to criticize on that and see how we can improve. Okay. Let's say we have on the supplier side, we have a class called cart for shopping cart. Okay, you know, if you purchase something from Amazon, you can have your electronic cart. We have a feature called orders. Orders simply an array of order, right? You can see now I instantiate G by order. And then we also have a second class called order. And then the order simply got price and quantity, okay? So if I want to know the value for a particular order, multiply price by quantity. From the client side, I have another class called shop. So we got three classes in the context. And then we have a cart of type cart over here, right? And then for the checkout, it's going to return basically how much do you have to pay according to your cart. Well, it simply go from until loop and then simply multiply everything, add them up, okay? Any problems with this design? Implementation-wise, that should work. But now, what's the problem?
If the customer changes his mind and he doesn't want the certain item, this code cannot remove it.
Oh, I see. You're just adding. You are expressing your concern that, for example, we don't have any feature in the shop class. Maybe add order, remove order. That's not our concern. Yeah. Let's say it's there. Okay.
We have no notion of doing because we're contracts.
Well, actually, even without the contracts, even if you put some contract, let's say for checkout, for let's say even if you put the complete contract for checkout, it's still not a good design. Oh, let's say what you're asking, what if somehow the array has to be grown dynamically? That's fine. You can also deal with that from the supplier point of view, right? But it's something more fundamental. I'll give you a hint in just a moment. I'll take one more answer. Well, that sounds a little bit general, right? When you say solution is not general, that's too general answer, right? What do you mean you say solution is not general? Right? Can you elaborate on that? You might be on a good track.
So if any other clients try to use the same thing with different feature, it won't work.
Okay, for example, you can see currently the client is using the array. That's from the supplier using the checkout. They can just use a loop. Let's say another client, they want to also manipulate this array. They can also use it, right? So that's not really a general, something about the problem not being general. Although, when you say the solution is not general, that's the correct answer. I'm just saying it's too vague, right? So that's why I want you to elaborate. I'll give you a little bit hints. Here is a design principle for you as a supplier. You should have absolute freedom to change your implementation strategy. Number one, for example, maybe you decide to change your heap implementation from an array into a linked list for some reason, or into a tree structure. Number one. Okay, let me write it down for you. It's really important because later on when we talk about design patterns for other cases, it's always important to realize. Okay, what I will do is I will switch to iPad. I'll write down the two principles for you. Number one, as supplier, you should be free to change implementation strategy. That's number one. However, number two is very concerned about number one. Number two is when you want to change your implement strategy, you better not affect anybody else. I'll write it down first and I'll explain what I mean. When you change implementation strategy, all existing clients should not be affected. Let me illustrate why this number 2 would be violated. Let's say this. We're under supplier. I'm not happy with the array, let's say. I change that to a linked list. Now, is my existing client who is shop, is it going to be affected?
Yes.
How?
Because it assumes that you're using an array.
Yeah, exactly, right? You can see exactly, for example, lower here doesn't exist for linked list. Upper doesn't exist for linked list. So what the consequence is, client's code won't compile anymore. That's pretty bad. I'll give you another analogy. Imagine that there's always some updates on Java library or let's say Java library. There's always some to say maybe they change the way they implement array list or they change the way they implement tree set. However, any change they made, it should not affect any existing code you have been implementing using the array list or the tree set, right? They only update internally. Yes?
Is it the job of the client or the supplier to do their code where like they wouldn't have a problem with the second?
Yes. So now we're basically talking about what should be the balance between the client and the supplier. Okay, I'll make it brief. Basically, from the client's point of view, it's fair game. Whatever API that reads to me, I can use this method or feature this way. For example, I can use the order. I can use the orders as an array of order. I should be able to use it, and that should remain stable. From the supplier's point of view, I should really provide stable API to my user. Anytime I want to change something, it's better being done secretly without affecting them. So it's more like two sides of issues. But this current design is not going to achieve that. Because if you want to modify the orders from array into linked list, order itself is public, right? That's a problem. Anytime you change anything that's public, it's going to affect anybody else. Yeah?
So is the supplier always free to change?
Yes, because supplier, they are basically, because it would be quite unrealistic for you to keep a single implementation throughout the lifetime of your project, right? Maybe sometimes you find out, maybe array or tree is not the best way to implement this particular application. You want to change that into something that's more efficient or something that's more specific to the way you're using the application. So you should be able to change it. But when you change it, you want to make sure nobody is affected. Okay. Yeah?
Maybe we should override lower and upper in our supplier code. So we introduce lower and upper. Whatever the client do, it won't break.
Yeah, so you basically, that may not work because what we're assuming that is, the array class over here, they already got a lower and upper, so it's not realistic to change them, right? We want to keep that over there. Okay, so now number 1 and number 2, that's really important principle for you to remember. Okay, so now it comes to this particular principle called information hiding. Okay. You keep hearing me saying 2 principles all the time. One is called single choice principle. We haven't seen an example just yet, but we'll see that. Number 2 is information hiding. That's also very important. Okay, let's go over some slides. And that's the issue. And now the solution to this particular problem is we should somehow try to hide. Okay, for example, you might want to hide orders being just an array somehow. But you don't want to hide the orders, the feature name itself. You want to somehow hide the fact that it's an array or a linked list. What we will do instead, when you see the ultimate solution, the ultimate solution I'm going to write in pink. Rather than having array or having linked list, what you will see is something we will say orders, and then it's going to say iterable. And then it's going to be itself generic, and then we'll say order. As far as the client is concerned, all they want to do is just to go over the orders collection one by one. That's the only purpose. So it doesn't really matter under the hood, that's an array or a linked list. So the iterator pattern is going to just create an abstraction, extra layer, to hide both the linked list and array or anything else. From the user's point of view, you only see iterable. Okay, but I'm going to make it more clearer a little bit later. Guys, any questions? Please, before I get to a little bit more technical. Yeah.
So can we actually use the across instead?
You know what? Your question was, can we use the across instead? Yes, across would be the ultimate way to go, but the across is exactly the consequence of implementing the iterator pattern. You're talking about solution already. Oh, I'm glad you're surprised, right? Good, good. Yes. By the way, across. Maybe I mentioned that maybe informally. The reason that you can use across on any collection is simply because any collection in IFO is iterable. I believe that might be the case in Java as well, right? You can use it for each loop on every collection object. The same idea. Okay, good. So now let's go on to the slides and go over a little bit more definition. Okay, client's code must be modified. In that case, that's the best thing, right? Whenever you change your implementation strategy, the client's code must be modified. Otherwise, they wouldn't compile. That's very bad. Very, very bad. Oh, that's the iterator pattern. Don't worry. So if you want to see a much cleaner version of that, go to the lecture site. There's a PDF you can open. Okay, I'm going to go over that on the iPad in a moment. Information hiding principle. Let's go over that quickly. What's information hiding? Okay. Just to interpret that literally, you're trying to hide something from the clients, basically. So what do you want to hide? Basically, anything for the supplier that might be changed constantly, they should be hidden. For example, implementation, they should be hidden. So now we say hide design decisions that are likely to change. And the consequence of that is stable API. You can see there, let me give you another analogy over here. Just draw something. Okay, think about from the let's say this is supplier. Okay, let's say let's say this is a supplier. Okay, and this is a site for the clients. Conceptually, think about there are two parts for the supplier. Okay, one part is the public part, the API. I'll use green. This is the part that's public. Okay. So this is the API that's public. Any clients will simply just use this part. Remember the client-supply relations we talked about, right? The other part, which I'm going to draw in slightly darker color here. In that case, I'll use maybe this. So this part over here is secret. So this is the design secret that's hidden. Anytime you want to perform any changes, they should be affecting only this part. And given that they are secret, they're hidden, they are not going to affect any existing client. Conceptually, that's how you think about, right? So every time when you're designing your class, first think about which part should be the green one that should be stable. Once you publish your API, they should remain stable. You'll be very bad if you try to change your API, right? On the other hand, the darker side, the blue one, that's secret. That means that part you can feel free to change from time to time, right, as you wish. Okay. Any question about this concept over here, right? It's, you'll see a similar diagram if you read the textbook, but that's all you need to know. Let me go back here. And then, okay, change of the secret does not affect the clients using the existing API, right? So you may change from array into linked list. Okay, okay, that's about the information hiding principle. Okay, that's the simple definition. Any question here? And now we'll talk about iterator. Okay, before I talk about iterator, there are two cases for the implementation. In the case of the lab 2, you will do the harder case, not the easier case. But I'll explain both cases to you anyway. But before I do that, I think it will involve quite a bit of coding. Before I jump into details, I want to go over one more diagram with you. Okay? Actually, two more diagrams before we go to the code. Okay? Okay, number one, I want you to look at this particular thing over here. Okay. Oh, of course you don't see that. Yes, over here. Okay. Basically, first of all, before I try to show you the class definition for the iterator, let's understand how iterator should be run at the runtime, first of all, right? And then we talk about architecture, and then we talk about code. We go bottom up. We go top down. Okay, so now let's say this. We have a class called array map. So this is our application. That's the class we are being the supplier of. And now, in order to make it implement the iterator pattern, step number 1, we have to say that class inherits, inherits, that's a keyword in iPhone. That means extends in Java. We want this class to inherit iterable of some type over here. I'll talk about the type in just a moment. Okay, that's step number 1. So what does that really mean? Inside this particular array map, we have 2 attributes. We have names and we have records. For example, we might have, name is Alan, and the record is simply just 2. And then we have Mark, and then it's simply 10. Okay, we just have a very naive implementation. We have one array that's names, the other one that's called records. Okay, 2 private linear structures. Okay, so now from any existing clients, they cannot get access to these 2 attributes. Okay, number 1. Okay, let me just do it from here. Any clients of array map cannot access these. They cannot, number 1, because we hide them. Okay. How do you hide them? In Java, you simply declare them as private. How do you hide them in iPhone? You will export them to none, right? You will simply say feature, and then you will say export it to none, okay? So now the question is, for any potential clients who actually really want to go over this particular map, I want to really go over Alan 2, Mark 10, and this record, and this record one by one. How can they do it? Because they simply don't have any access to the private attributes. How can they do it? So this is where iterator pattern can come handy. Okay. So what we make public is in this. So now, whereas these 2 things are private, what we make public is a feature called new cursor. Okay, new cursor is public. Is the only way for iterating over the hidden structure. Okay, that's number 1. And every time if you say your class inherits the iterable, you will be obliged to implement the new cursor. So that's exactly what you would do in lab 2. If I want you to make a class iterable, you would say inherits iterable of something, put something there, and then you got to implement a new cursor feature. Okay? So now let's go a little bit further before we look at the architecture. Because the new cursor right now is simply just public. So imagine something like this. Let's say we got AM, it's array map from the clients. So now, if the clients actually now want to go over the array map one by one, so this is a typical thing they will do across, okay? But rather than writing across, I'll write it a little bit different way. They can say from cursor is assigned to AM, the array map dot new cursor. That means I know that I cannot get access to the two private features of array map. What I would do is I'm inquiring for the new cursor, okay? And then until cursor dot after. So these are all features you should know later. After simply means I'm just going to go over the cursor one by one until there's no further position for the cursor. That's pretty much how you implement stuff, back in the previous courses. And then I can say loop. And then I can simply say something like, maybe I can say print, for example. I can say print cursor dot item, and then end. Okay, I'm gonna highlight some stuff here for you. First of, basically you have return the new cursor from the structure you want to go over, and then just run a loop using after and also item. That's basically what you're going to do, right? You're just using the cursor itself to go over the items. So at the runtime, as soon as you say new cursor, it's going to give you this particular object over here. So that's of type. Well, I'll go over this class name. It's called iteration cursor. It's just existing class. So once you go to the cursor class, let me finish this and I'll take your question. Yeah. And then once you go to this particular iteration cursor, okay, what's going to happen is it allows the user to call either item or after or forth. Oh, so there's something I forgot to mention here. So make sure it doesn't loop indefinitely. You got to say also cursor dot forth. Okay. Okay, let me just highlight it. So cursor dot forth. But want to make sure you move the cursor to the right by one position every time. From the client's point of view, they can only call item after and forth. But the cursor, when you implement the cursor class yourself, they may also get access to the private feature, but that's okay, it's still hidden. Okay? So now when the user call item after and forth inside the context of a loop, basically what you will get at the runtime is using the cursor objects, you can get access to this maybe as a tuple that will simply give you maybe Alan and then 2. And also when I go to the next position of the cursor, it's going to give me and also Mark and then 2. However, the user has no knowledge about how these two structures under the hood is implemented. All the user care is they can call item. That's all they care. They call item to get something from the underlying structure. Oh, okay, I'll take questions. Yes.
Is it Mark 2 or Mark 10?
Mark 10. Yes. There's no complex arithmetic here, so just typo for sure. Thank you. Mark 10. Guys, excuse me. Any question? Yeah.
So if we have to declare the cursor,
Yeah.
what type of it?
Very good question. So this, there are two details I haven't really explained in detail, but at this level, so there are two things I kind of left unexplained. So one is about one thing here. When we say the class inherits iterable, over here, what should be the type over here? Number one. And then when I say iteration cursor, what should be the type over here? That's number 2. Okay? So that's the tricky thing you have to solve for lab number 2. Okay? So now, I have a tip for you. Okay? Over here, first of all, can you confirm with me that if you look at that, this type over here after iterable is tuple of string and G, right? That one matches tuple, string, and G. Typically, these two types simply just match, number 1, okay? Number 2, what do they really mean? What they really mean is, I'll put it here. What they really mean is when retrieving an item from array map, what should be the item's type? That's conceptually how you can think about. Okay? For example, you can see over here, since we say it's a tuple with the first element being a string and the second element being G, like a generic. What I mean is, if I try to read from the user point of view, when they call item over here, the first one they will see is simply a tuple with Alan, the string. The second one is 2. And the second one is just another tuple. Okay? That's roughly speaking, right? At this. I haven't really spoken about exactly how you can figure out the type, but that's to be discussed. Question? Yes. Cursor the item returns an object, correct. Basically, cursor the item over here, okay? I'm glad you asked. Cursor the item over here, what should be its type? Its type corresponds to exactly this tuple. Okay? Yes? The cursor position, basically, that one there, when I say cursor position, that's exactly about how I implement the cursor itself. So that's a particular implementation. So somehow you want to keep track of where the cursor is. Maybe the cursor is now pointing to position 1 of the underlying data structure, and then it will move to position 2, and then position 3. Yeah, but the user, the client, doesn't have to know about this.
So the array map inherits sort of a generic type.
Mm-hmm.
So then would the array map have to have a generic type as well?
So yes, array map may be generic, but here I'm just trying to show you the rough idea. So yeah, that's something you got to decide for the lab 2, yes, or for any application. Okay, so that's about the runtime. So just to give you a little bit more intuition, basically, again, something will be hidden. In order to retrieve something one by one, for the user, for the clients, you have to create new cursor. And that's a consequence of inheriting from iterable. Okay, that's conceptually what you should know. And now, let's go over a little bit about the architecture. Okay, and then hopefully I can do a little bit of example. Otherwise, we can continue from Thursday. Okay. I'm actually thinking about what would be the best way to do this. Okay, let's do this. I will explain the diagram maybe on Thursday. For now, I want to show you quickly the 2 cases so you can do a little bit self-study. So tomorrow you can still do something in the lab. Okay. I will start with this diagram on Thursday. So now I'll do a little bit different. Let me go to the code directly. Okay, so now how do we implement an iterator pattern? Basically, the way to implement an iterator pattern, there are easy cases and hard cases. And not surprisingly, you got to do the hard cases for lab 2. Okay, but now, easy case, I'll show you quickly. Okay, so now, how can you make your class iterable? First of all, let's imagine that that's what you start with. You have a normal class, which just normal, orders of array, but now array is hidden. So now how can any potential clients get access to the orders one item by one item? Okay. What I would do, first of all, I would say inherits iterable. Now, what should I put over here? Think about from the client's point of view, if they want to get access to the cart item by item, what should be the type for each item? Should be quite obvious in this case, right? Just they want to retrieve order by order, regardless of the ordering. So I'll simply put order. That's step number 1. Of course, it will be a little bit more complicated for you to decide for lab 2. Okay, you got to struggle with that a little bit. So now, what's the next? The next to do. Every time, if you try to inherit from the iterable basically is a deferred class, right? Remember we talked about this sign, right? That means deferred. Iterable of G, any G, basically. And then there is only a single feature in iterable called new cursor. Okay, does that ring the bell? I just mentioned that a few minutes ago. New cursor, that is going to return iteration cursor of type G. And then that one is also deferred. That means every time if you say my particular class inherits from iterable, I must now define new cursor. Otherwise, my class will be deferred as well. Okay? So now the next step is to say feature, and then you can just call maybe cursor. How about this? And then I can say new cursor. And then I can say iteration cursor. Now, iteration cursor, remember I said before, these 2 types, maybe here. This type for iterable and this type for iteration cursor, normally they match, normally. So now, what should I put over here? Order, thank you. Now, what should I implement over here, right? Since I talk about it's easy case, it's a one-line implementation. The idea is simple. Every collection class is iterable. And given that every collection class is not deferred, that means they have already implemented their new cursor feature. Why don't we use it for free? You see my logic? So I can say result is simply assigned to orders dot new cursor. That's it. That's why I say it's the easy case. And maybe you wouldn't do it anyway. Yeah, but maybe you never get to do it. It's yeah, maybe an exam. I don't know. Yeah. Okay, guys, any question about this easy case? Right? The easy case again, basically saying if your data structure is simply just a collection class alone, in that case, reuse the new cursor from there. That's the easy case. Okay, now let's talk quickly. Do we have time? No. Okay, no worries. So what I will do is I will release the lab tonight. Look at that, and then I might do a little bit of illustration tomorrow in the lab just to get you started. But don't worry, you have enough time before it's due. Okay, I'll see you on Thursday.